Guys, here's a fun fact. Did you know that the stuff that you learn in grade 7 and grade 8 and grade 9 and grade 10 and grade 11 is a building block of the question paper that you're going to have to answer in grade 12? Meaning, if you miss the basics, chances are it's going to be hard for you to answer that final paper for you to can determine if you're going to go to university or not. I'm talking to high school students right now. In most cases, whenever you hear someone mentions Pythagoras theorem, I know that what's going to come to your mind is a triangle, which is a right triangle, of course. And then from then, you know that you can play around with your trigonometric identities, right? But now, whenever you are considering that triangle, it matters as to which quadrant of a Cartesian plane is the triangle. Because most people don't care. You would be calculating the X side or the Y side. Actually, to make sense, let me draft it down so it makes perfect sense. Look at it like this. Now, in a perfect world, like I say, whenever you hear Pythagoras theorem, you think of a right angle triangle, and then I've placed a beautiful right angle triangle there. Suppose you are given two sides. Hypothetically, suppose they told you that sine theta is equals to 1 over 3, for in case. At that moment, the students knows that sine theta is opposite over hypotenuse. Opposite over hypotenuse. And we know that in terms of x and y, sine would be y over r, right? So I'm going to name this side r, I'm going to name this side y, I'm going to name this side x, because at some point, ideally, I believe at this point, you know this. Therefore, it means you are given this side and you are given this side, because sine is y over r, meaning y is equals to 1, r is equals to 3. And then suppose now you have to determine the value of x. Students who understand will then know that I will use Pythagoras theorem. Therefore, you may say y squared plus x squared is equals to r squared. I'm not concerned with that. And then you're going to go and say x squared is equals to r squared minus y squared. Therefore, you will have your r squared to be. Therefore, you get to the part where you know that x squared is equals to 8. But then you are looking for x. So meaning you're going to have to put the square root both sides. Therefore, x is going to be plus or minus 2 square root of 2. You can punch this value to confirm on your calculator. I don't have time to explain this for now. But here's the thing. Now that x is plus or minus, how do you determine if you take the positive number or the negative number for x? And now I'm here to tell you that you use based on where your R is at. So in this case, R is at the first quadrant. And since it's the first quadrant, I know that X is positive here and Y is positive here. So I would choose the positive value for X to be 2 root 2. And again, you don't necessarily have to picture a triangle whenever you think of Pythagoras. You can remove this and write it nicely in the form of the radius, and then you show the point there. So you know that your point here would be 2 root 2 and 1 for y, because that's the point where the 2 meets. So in this case, when it's in the first quadrant, we know that x will be positive and y will be positive. Now, we're going to carry on with that spirit. What happens now when R is on the second quadrant? When R is on the second quadrant, we know that X will be negative and then Y will be positive, because this is a positive value for X, this is a negative value for Y. What happens when R is on the third quadrant? When R is on the third quadrant, we know that X will be negative because that's the negative side for X, and also Y will be negative because that's the negative side for Y. What happens when R is on the fourth quadrant? When R is on the fourth quadrant, we know that for X, it will be positive, and then for Y, it would be negative value. Meaning, If we go back to the first quadrant, we know that for both x and y, r is positive. So whenever you are using your Pythagoras theorem, whenever you are using your Pythagoras theorem to determine a value, at some point you're going to have to determine based on the square root if it's a plus or a minus. For you to choose whether you take a positive value or a negative value depends on the quadrant of where R is. This information is very much important, guys. Now, with the information that I just explained now, it gives us a path to can answer the question that we selected today. So the question that we have today is 1.2. And the question reads, we have to make use of the diagram below to answer the questions without the use of a calculator. And we are given a Cartesian plane. And we can see that in this case, although the value of R is not specified, but we can tell that R is on the fourth quadrant. And since R is on the fourth quadrant, we have a point P, which is 3 and minus 4. We can see that 3 is a positive and minus 4 is a negative. Let's put it on the... So this is the situation that we have. We can tell that X is equals to 3 from here, Y is equals to minus 4. And then what do we need? We need the value of R for us to can answer any of the question. So now R squared is equals to X squared plus Y squared according to Pythagoras theorem. And then now we know that this is going to be 3 squared plus minus 4 squared. This is going to be 9 plus 16, which gives us 25. Now I know that R squared is equal to 25, but then I'm looking for R. Now I'm going to put the square root both sides. Therefore, R is going to be equals to... Now, here is something which I didn't specify. When coming to the value of R, R is always positive in this case. So R will be 5. We don't... Even though when I put the square root mathematically, the answer would be plus or minus 5, but the value of R is always a positive number. So R is equals to 5. And then now I'm in the right path to can answer each and every question that was asked based on that. So the first question I had to determine 1 over 4. Let me just write the question there. So it's 1.2.1. I have to determine 1 over 4 sine squared theta based on this. This is the same as 1 over 4 sine theta squared. But what do I know in terms of x and y? I know that x is 3, y is minus 4, r is 5. And in my knowledge, I know that sine theta is equals to y over r, which is opposite over hypotenuse if I was looking at it in terms of a triangle. But otherwise, this means that sine theta is y is minus 4 over r is 5. So this is my value for theta. So then I will then say 1 over 4 minus 4 over 5 squared. Therefore, if I simplify this, I will have 1 over 4 times minus 4 squared is going to be 16 over 25. And then if I simplify this further, obviously 4 here goes into 16 and 4 goes once into 4 and then it goes 4 times into 16. Therefore, 1 times 4, this my final answer would be 4 over 25. That would be the value of 1 sine squared in terms of that. But otherwise, if you are not sure of this, you can punch it on a calculator right ahead from here. But at the end of the day, this is what we get. And then for 1.2.2. Now, for 1.2.2, using the same diagram, I have to show that sec squared theta minus 1 is equals to 10 squared theta. I will start with the left-hand side first. So for the left-hand side, I have sec squared theta minus 1. And I know that sec squared theta is the same as sec of sec theta squared minus 1. Now, there are many ways to attempt this question. One may substitute 1 over cos theta here squared minus 1 and then approach this in terms of theta. But There are many ways to approach this. Let me show you another awesome way. Ideally, let me picture what cos theta is based on this. I know that cos theta is x over r. I know that cos theta is x over r. If cos theta is x over r, I know that sec theta will then be r over x because it is its reciprocal like that. So if cos theta is x over r, I know that in this case, cos theta would be 3 over 5. And then that makes sec theta to be 5 over 3 because, like I say, it's reciprocal like that. So therefore, this means I will then have 5 over 3 squared minus 1. Therefore, this is going to be 25 over 9 minus 1. If I simplify this quickly, I will get that this is the same as 9 is to 9 by that is 25. And then 25 times that is going to be minus 9. This is going to be 16 over 9. So that's what I get for my left hand side. Now let's go for my right hand side. For the right hand side, I know that I have tan squared theta, and I know that tan squared theta is the same as tan theta squared, like that. Now, what is tan theta in terms of the diagram that I have here? Since I know that tan theta is the same as y over x, which is the opposite over the hypotenuse. In this case, it's going to be y is minus 4, x is 3. So that is tan theta. So then if I put that in here, I would have minus 4 over 3 squared. This is going to be minus 4 over 3 squared is going to be 16 over 9, which is exactly as the right hand side. Therefore, I can conclude that my answer, therefore, the left hand side is equals to the right hand side. Then I have shown that sec squared theta minus 1 is the same as tan squared theta minus 1. So in other words, what I'm trying to say is let's learn to be advanced with this mathematical thing. Let's not always assume that a Pythagoras is always had something to do with a triangle, although it is, but then don't look at it as a triangle as such. Sometimes we can be advanced and present it like this. Don't forget to subscribe to our YouTube channel. Follow us in all our social media platforms. I'm Mr. Maimane, and this is Simplified RSA. We are the guys who make sure we make it looks easy for you to can attack those exams.